Hey gang, we got another probability video here. This time we're going to look at a contingency table, which is a nice way to organize and display information in two variables. Let's pop right into this example. A recent survey from a random sample of 6,549 adults from Grand Rapids, Michigan resulted in the following. So here is our contingency table. There are two variables displayed here. One variable is smoking status and the other is income level. And we've got either smoker or non-smoker as two categories there. And then income level has been categorized as either low, medium, or high. And we've got our total sample size in the bottom right corner there. I'm going to ask several questions here. They are written to the left. I've got some more queued up. Let's go. Part A, let's fill in all the total values in the table. So we're going to look a little bit more closely here at the cells in this table. Each individual in this sample provided two pieces of info, one for each of the variables. And so we can see here that there were 634 people who were both in the low income and smoker categories. If we add up the 634 along with this 1846, that would be the total number of people who were in the low income category. And same thing here with the medium income, the 1622 plus the 332 would give us the total for the medium income. Similarly for the high. And we can also add along the row here, the total number of smokers would be 634, 332, and 247. Let's get to cracking. And we have our total sample size there, which I suppose I can call N, right? That's N is 6,549. And the sample size should be the sum of these totals, either vertically or horizontally. Let's double check. Indeed. Okay. So part A, we have completed that task. Check. Let's answer part B. How many adults in the sample are non-smokers? Okay, non-smoker, total of non-smokers, 5,336. Not too bad. What proportion of adults in the sample are non-smokers? So proportion almost always means there's some sort of division occurring. Another way to think about the proportion here could be as relative frequency, where we would count up how frequently was a non-smoker observed. Well, 5,336 out of the total 6,549. And I spelled frequency wrong because I got my brain and my hand mixed up, but that's okay. Part D, what proportion of adults in the sample are in the high income bracket? Okay, So again, a proportion of adults in the sample. So we'll divide by 6,549. It's the total of the sample. And high income, that is 2115. 2,115. Cool. So we actually haven't been asking any of these questions in terms of probability. These have been observed proportions from the sample. This is basically relative frequency. But I'm going to rephrase these questions in a way so that we are discussing probability. Okay, I've got several more questions geared up for you. And we're going to assume that an adult from the sample is selected at random. And we're going to answer the question, but also rewrite it using our probability notation. Let's start with part E here. What is the probability that the randomly selected adult is a smoker? With the notation P parentheses smoker. And I'm just going to write out the letters for smoker. I could have probably defined a shorthand event, but this is fine for me. Well, probability can be estimated empirically, where we are using information gathered from a sample via observation. It's basically the same process that we did over here in parts C and D. Well, let's just count. How many smokers were there? 12, 13 out of the total. 65, 49. Sweet. Let's scroll down to the next one. What is the probability the adult is a smoker and a non-smoker? So notice the word "and" there. So that would be the intersection, right? That is the intersection. And it's really tempting to jump in and let's crunch some numbers, let's go. But let's step back and think about this question. If you were presented with this survey, you're going to check only one box, right? Either you consider yourself a smoker or you do not. So can you typically be considered both a smoker and a non-smoker at the same time? Probably not. So the probability that a randomly selected individual is a smoker and a non-smoker is 0. Right? These are disjoint events, or mutually exclusive, right? Disjoint events or mutually exclusive. And we said 2 events that are mutually exclusive cannot occur at the same time. And this question was asking, what's the chance that these 2 disjoint events are happening at the same time? That probability must be 0. Let's look at the next one. What is the probability that the adult is a high income earner or a smoker? Or. Hopefully the word "or" reminds you of the addition rule. Addition rule. And we're going to compute this using the formula for the addition rule so everything is consistent. Certainly there's other ways you could do this with information from a table, but I would like to follow the formula. So probability, got to start over here, that we've got a high income earner or a smoker. We are going to get the individual probabilities. So we first need the probability for high income, the probability for smoker. So we'll add those. Let's start there. High income, so that will be the 2115 out of 6549. The number of smokers, 1213 out of the 6549. So we've got the individual probabilities gobbled up, but notice we have a double count, right? We counted up all the high income individuals, whoop, and we also counted up all the smokers. And didn't we double count a certain number of individuals? Aren't we double counting these 247 individuals there? So we need to erase, subtract the double count of 247 out of 6549. So I'm going to annotate that here. This was the double count. And adding and subtracting all of those gets us 3,081 over 6549. Sweet. Maybe I should put all my answers in boxes. That's always pretty good practice. I've got 2 more questions to ask here. I've copy-pasted our table here just for viewing pleasure. Let's go. Part H. If the selected adult happens to be a smoker, what is the probability they're in the high income bracket? Notice with this question, the probability of interest is what's the chance they're in the high income bracket? Probability high income. But notice that they are giving us a particular set of circumstances. If the selected adult happens to be a smoker, so that is conditional upon that happening first. So this is the probability that someone is in the high income category given that they are already a smoker. So here we've got a conditional probability that we will be considering. Let's see how we determine that with this contingency table. Remember, with conditional probability, we are limiting our perspective to that only of smokers. Our sample space is limited only to this group. So I don't even want to look anywhere else. Don't look at you. I'm not looking at any of you. So first, an individual has to be a smoker, and that occurs with a certain probability. So that needs to be in the denominator. That is the 1,213 out of 6549. In the numerator, we need the intersection of both of these categories, high income and smoker. So we need to look at high income and smoker. So that's going to be the 247. 247 out of 6549. And as you can see here, these handy dandy divisions by 6549 will cancel, and this will simplify 247 out of 1213. So conditional probability, notice this 247 came from the intersection, both high income and smoker occurring together. Let's do that again in part I. In part I, we again have another conditional probability. But this time, notice the categories are flipped. If a random selected adult happens to be a high income earner, what is the probability they are a smoker? I'll paste another table here for our scratch work with the notation probability that they are a smoker, the set of conditions given that they happen to be in the high income bracket. Okay. So we've got all the same words, but they are rearranged. So we're not going to have the same answer. It'll be something different. And to facilitate here with the formula, I'm going to kind of write out the steps. Here we just went straight to the numbers, but I thought it might be valuable to actually see the formula here. In this question, we are limiting our perspective to that only of the high income group. So this time I'm going to not even think about these two groups here. We are limiting ourselves to that of high income only. So in the denominator is the probability of that occurring, which is 2115 out of 6549. That's probably going to cancel again, but I'm going to be thorough. In the numerator, we need the intersection of the events of someone being a smoker and high income. High income. And that refers to these 247 individuals out of the sample size, which again, these divisions by 6549 shall cancel, and we get 247 out of 2115. So in this video, we've done a lot of probability properties, conditional addition rule, mutually exclusive events, but also in the context of something mildly new with that of a contingency table. Hope you enjoyed it. See you in the next video.